Hello again, and welcome to Maths is Not a Mystery. We're going to be looking at surds today. There are two videos about surds on Maths is Not a Mystery. The first video is this one, simplifying surds. Let's just be quite clear what a surd is first of all. It's what's known as an irrational number, and it's a square root that you can't really work out. So where, for example, the square root of 9 is quite clearly 3, the square root of 10 is something that's a lot more difficult to pinpoint. It's a long decimal that probably doesn't end. And so rather than trying to work out the exact value of it, we leave it simply as a square root. However, sometimes you can be asked to make a simplification of a surd. And what that means is that you have to follow a certain group of patterns. Now, I've started here with this idea of simplify the square root of 50. Now, whenever you're going to do a simplification of a surd, you need to think about the factors of the number that we're dealing with, and you need to see if there are any factors that are square numbers. So you think about the square numbers 1, 4, 9, 16, 25 and so on, and see whether one of those numbers will divide into the number that we're dealing with. If more than one will, then of course you use the biggest, because we're always going for the biggest factor, highest common factor, as you've done in the past. Now, think about 50, and the factors of 50 that include a square number could be 25 and 2. So what we could change here is we could say that the square root of 50 is the same as the square root of 25 times the square root of 2. 25 times 2 still makes 50. It's still equal. Whatever the square root of 50 is must be the multiplication, the product of the square root of 25 multiplied by the square root of 2. The difference here, however, means that we know one of these. We know that the square root of 25 is 5, so we can write that as a real number. We don't know what the square root of 2 is. That's still an irrational number. So we finish this surd off by saying that the square root of 50 is the same thing as 5 lots of the square root of 2. And that's it. That's completed the simplification of that surd. Okay, and you don't work it out any further than that. You don't have to work out what the square root of 2 is, because you'll get a ridiculously long, unmanageable decimal that simply won't mean anything. Now, sometimes you can start off with a bigger problem at the beginning. This is 3 lots of the square root of 75. Simplify that. Well, okay, we're going to change this to 3 lots of the square root of 25 times the square root of 3. And you see what I've done here? The 75 part, I've broken it down into its factors, making sure that there's a square number involved. 25 times 3 makes 75, but there were 3 lots of them to begin with. Now, that means that we know that there was already a 3. We now know that 25's square root is 5 times the square root of 3. 3 5s are 15. We don't know what the square root of 3 is, so that's our final answer. 15 times the square root of 3 is the same as 3 lots of the square root of 75. And if you try it on a calculator, if you type in the square root, you ask it to do the square root of 75 and then multiply that by 3, make a brief note of your answer, and then ask it to do the square root of 3 and multiply that by 15, remember that when you've got your answers each time, you then have to times them by themselves to get the actual real number. You'll get the same number. Now, the one below follows exactly the same pattern, but it has an extra little complication, because you might be asked, just like you are with fractions sometimes, to fully simplify a surd. So let's take a look at this one. 108 The best that I can think of to multiply it using a square number would be 9 twelves. So 108 could be the square root of 9 times the square root of 12. We then know, of course, that 9 has a square root of 3. And we don't know what the square root of 12 is, so it becomes 3 lots of the square root of 12. However, you always need to be on the lookout to see whether inside your root position here, inside the square root, can we go further? And 12, of course, is the same as 4 times 3, and 4 is a square number. And if you can get another square number into this, get another square factor, then you can go further. The clue would be in the question if it says fully simplify. It's usually a little clue that getting to here, well, it will get you a mark, but it won't get you full marks. So 12 is the same, the square root of 12 is the same as the square root of 4 times the square root of 3. We've already got in front of it, it's 3 times that lot. So far we've now changed this to the 3 there, that was already there, times the square root of 4 times the square root of 3, which are the square root of 12. Let's take that a step further. 3 times 2, because the square root of 4 is 2, times the square root of 3. Now we can just do the simple piece of work on the outside. 3 2s are 6, times the square root of 3. And now we've completed it. We don't know what the square root of 3 is, and it doesn't have any factors that will take us any further. There are no square factors in there. So always watch out if when you think you've finished, the number that you have inside the square root box could still go a step further. If it has a square factor, then obviously break it down further. Now that was using multiplication there. You may be asked sometimes to do a simplification with a division. This is fairly straightforward as well. The square root of 50 over 121. The first thing you're going to do is you're going to change it to the square root of 50 over the square root of 121. That means exactly the same as the original part of that. Now immediately I can say that the square root of 121 is 11. So it's now the square root of 50 over 11. We've finished with the denominator, we've finished completely with the bottom of the fraction, but we haven't finished with the top of the fraction because the square root of 50 can, of course, be simplified. We did it earlier. So the square root of 50 could be the square root of 25 times the square root of 2, all over 11. We know that the square root of 25 is 5 times the square root of 2 over 11. And that's now finished. You can't simplify that any further. That's already become a real rational number. And therefore, we've completed that simplification. The next question is an addition question, and it could also be a subtraction question, and it would work exactly the same. I'm only going to do one. This is incredibly straightforward to simplify. Basically, all you have to do is we've got 5 lots of the square root of 6 plus 4 lots of the square root of 6, and it's as easy as this. That adds up to 9 lots of the square root of 6. We're simply adding the extra numbers on the outside. If it had have been 5 minus 4, then it would have been straightforward 1 lot of the square root of 6. Okay, so the addition and subtraction versions are extremely simple. You won't be given things where the numbers, like the root of 6, it won't say the root of 6 here and the root of 8 there. It will always be the same number inside on your questions, but the outside ones, you just add them or take them. Now you might see a question that looks something like this, right? The square root of 180 in the form p times the square root of 5, where p is an integer. So what we're wanting to find out is what that number is that's on the outside of the square root box. So all we do is we simply think about the square root of 180 and we simplify it. And when we start to simplify it, Well, what can we use? Let's have a little think what we can be doing. The square root of 180, what can you multiply? 36 times 5. It's the square root of 36 times the square root of 5. Okay. We know what the square root of 36 is. The square root of 36 is 6 times the square root of 5. Hey, look, we've now got that form. P, outside the box, P times the square root of 5. 6 times the square root of 5. P is 6. It's not as complicated as the question would like you to think it is. You simply do a straightforward simplification, and the main thing you've got to do is check that the number that's going to be inside here, the square root, is the same as the one they ask you, and you're finding out how many lots of the square root of 5 it would become. So that's simplifying surds then. So it's all really about thinking about factors, thinking about factors that have got square numbers in them, and then once you've got a factor with a square number in it, you know its real answer. You can turn that into a real rational number, and then that leaves you with irrational versions, which are square roots that you can't work out. I hope that's been helpful. There is a second video about rationalising surds. It's important that you understand this one first, and we also have a book on Amazon available which is covering the whole section of simplification and rationalisation. Thank you for watching. I hope that's been helpful, and we'll see you again soon on Maths is Not a Mystery. Bye bye.